Hi, in this video, we're going to take a look at modifying the bandwidth for the use of the metric on serial links for OSPFv2. So if I do show interface serial 000, okay, depending on the iOS version, it's going to typically show me some default value for bandwidth, 1544 kilobits per second or 1.544 megabits. In this case, defaulting to a T1 link. That may not be the actual bandwidth on that interface, but what will be used for the actual metric is what's being shown here as far as bandwidth, that BW 1544 kilobits. Okay, so it's good to always check the show interface command, make sure it reflects the actual bandwidth on that interface for routing. we're going to be modifying this bandwidth, and I would use it on all serial interfaces because it's going to become part of your running config. And if for some reason you upgrade routers, change IOSs, or change interfaces, it may have a different default if you leave it to the default. Okay. So modified bandwidth values are shown in the running config. Now, changing the bandwidth, as we're going to do here shortly, doesn't actually reflect or change the actual speed, the bits per second, how many bits per second we send over that link. It's purely used for routing metrics. Okay, so let's say we have this scenario here. We have R1 that has a routing entry for 192.168.10.8. Okay, now the thing is, it actually has two paths. It has one through its serial 000, another one through its serial 01. The preferred path is that in purple because it's a faster link. 1544 kilobits is faster than 64 kilobits. However, if we don't change any of our bandwidth defaults, it's going to look like we have two equal cost paths, because as far as the bandwidth metric is concerned, serial links all have the same bandwidth values, same cost on these serial links. So what we want to do is modify the bandwidth values to reflect the proper speed of the link, what the actual speed of the link is. Okay, so let's go ahead and do that. We do that using the bandwidth command. We do this directly on the serial interfaces. And here we're reflecting the actual bandwidth for those. And I would actually also do it on R1's serial 000 and R2 serial 00, these two as well. But we just use the bandwidth command to reflect the actual speed of the link. Okay. So there's actually two ways we can do it. One way I just showed you, interface serial 001, bandwidth 64 for 64,000 bits per second. Okay. Another way we can do it, and if I do show, sorry, this is bolded here, show IP OSPF interface serial 000, it shows the calculated cost, okay, which is 15,625. So how did it come up with that? It takes the reference bandwidth and divided by the bits per second, which is 64,000, that gives us 15,625. Yep. Okay, this is assuming that this is our reference bandwidth is 1 billion that we had used previously in the previous video. Okay, but you know, there's another way of doing it. We can just use the IP OSPF cost command and say this is the cost that we want. So we can either use the bandwidth command and let OSPF come up with the calculation, or we can just statically configure the cost. It's probably, you know, there's kind of best practices for both, but you're definitely going to need the IP OSPF cost command if you, in a multi-vendor environment, that might not be using bandwidth to reflect the cost of the link. Okay, so that's modifying the cost. Modifying the bandwidth on serial links.